Okay, so hello guys. So today's our topic is actually going to be difference of the squares and the perfect square trinomials. Okay, so this is our today's topic. So as the topic said, you should know squares. It just simply like this, right? X to the power 2, x squared, right? Okay, so that is there is some basic information, and before we actually doing any questions, there are something really important information. Yeah, there are some really important information I want to tell you guys. Okay, so the thing what we have to say is that what is a perfect square, and then here is the definition. So let me read it. Okay, a perfect square term has a coefficient that is a square. Okay, so those are square is a keyword. What we mean square is the number over here. It's 1, 4, 9, 16. You may ask me why, because 1 is actually equal to 1 square, and then 4 is actually equal to 2 square, and then 9 is equal to 3 square, right? And 16 is actually equal to 4 square. So that's the meaning of the square. Okay, and over here, and any variable have exponent. So exponents has it and that are multiplies of 2. Okay, so this is another important part. Any variable, okay, any variable has exponent that's multiply of 2. So you can see the example over here, right? X, so let me write it. Okay, and so over here what we have is x to the power 2, which is equal to x to the power 2 multiplied by 1, right? And then y to the power 4 is actually equal to y to the power 2 multiplied by 2, right? And then z to the power 6 is actually z to the power 2 multiplied by 3, right? Okay, so those are basically all the multiplies of 2, right? Okay, I think you guys get the idea, right? So now let's look at the example over here. Okay, so let's look at the example. Our first example over here is 9x to the power 4, right? So 9 is actually equal to 3 square, right? And x is actually equal to x to the power 4 is equal to x to the power 2 multiplied by 2, right? Okay, so let me erase this part. Okay, so we can actually factor this, become this, right? So over here is 3 to the power 2, and then x to the power 2 multiplied by 2, right? So we can actually factor it. So it does become 3x to the power 2, right? 3x bracket to the power 2, right? Okay, so I think I make a mistake. Yeah, sorry, I think I make a mistake. So it should be 3x squared bracket to the power 2, okay? And you can see this is exactly the same as 9x to the power 4, right? It's exactly the same as 9x to the power 4, right? So yes, okay? So the meaning of the yes is that it is a perfect square. Okay, yes, it is a perfect square. Okay, it is a perfect square. Okay, sorry for the writing, but okay. And let's look at the I just want to put the line to make sure you guys see the answer. Okay, let's look at question 2. So example 2 over here we have 24x to the power 6, right? As we all know, 24 is not a perfect square, right? 24 is definitely not a perfect square, right? Cause over here we have 16 is equal to 4 to the power 2, right? And then 25 is actually equal to 5 to the power 2, 5 to the power 2, 5 square, right? So you know 24 is actually not a perfect square. So no, okay? It is not. It is not a perfect square. Okay, it is actually not a perfect square. It is not a perfect square. Okay, so let me write it down. Yes. So okay, so basically over here, 24 is, you cannot make 24 into a perfect square. Okay, so basically it is not a perfect square. Okay, right. So maybe a little bit more information about a perfect square. So remember, the perfect square have to be 1 to the power 2, have to be 1 to the power 2, 2 to the power 2, and 3 to the power 2. You can notice that, right? Well, those number 1, 2, 3, and then 4 to the power 2, 5 to the power 2. The number over here 1, 2, 3, 4, 5 are all positive number, right? So that's how we define a perfect square. Okay, the number over here have to be positive number, right? 1 is positive number, 2 and then 3, 4, 5, those are all positive. So that's how we define a perfect square. Okay. Right. So now is actually the time for us to doing some question to get some better understanding. Okay, to actually get some better understanding, and then. There's not many questions in this section. We only got 7 questions. Yeah, we only have 7 questions over here. So okay, so we're gonna do those questions one by one, really detailedly, and then I hope you guys okay. So I hope you guys can understand all of it and understand all of it. Okay. So now let's move into question 1. So over here we want to factor out each binomial. Okay, so we want to factor it, right? And we can see the first question what we have over here is m squared minus n squared, right? N squared, right? So we want to factor out. So maybe over here I want to recall one of the property. Okay. The one of the properties say is actually a plus b, and then a minus b is equal to a squared minus b squared, right? So that's actually, you look at the question 1 and you seem like the property we can actually use the property over here, right? So as the property says, right? So m squared minus n squared, it just becomes m plus n. Let me write them a little more clear. Yes, it just becomes m plus n and then m minus n, right? Okay, right. So I mean, we actually solving the question by just using the property. We just by basically using the property, right? So m plus n, m minus n is the solution for. We finished the factoring is the solution for question 1. Okay. Yeah. Okay. So question 1, I just want to give you a briefly start. Okay, and then let's move into question 2. Okay, question 2. What we have is we also want to factor it, right? So we want to factor it. We have 49 minus y squared. Maybe record it again. So remember, a plus b and a minus b is equal to a squared minus b squared, right? So you look at this question, it seems really familiar, right? So you notice that 49 is actually equal to 7 squared, right? So 49 is actually equal to 7 squared, and then it's minus y squared, right? So you look at it, it's quite similar. It's quite similar, right? So you should know that you should apply the property, right? So it just becomes 7 plus y and then 7 minus y, right? Okay. Right. All right. So this is gonna be, we finished the factoring for question 2, and then this is the solution for question 2. Okay. I mean it makes sense, right? As I said, all we do over here is just we just basically using this property, right? Okay. Okay, so let's move into question 3. Right? So question 3. So question 3 again, you know, we have to using the property, right? We have to using the property, this one, right? Let me rewrite a little bit. Let me actually rewrite a little bit. So we have property a plus b and a minus b equal to a squared minus b squared, right? So we over here we're gonna using this to factor out, right? So you can see what the question over here, what we have is 64y squared minus x squared, right? So 64y squared is actually equal to 8y squared minus x squared, right? So you notice that 664 is actually equal to 8 squared, which is the perfect square, right? And then, you know, y squared, so basically over here 64y squared is actually a perfect square, right? It's actually a perfect square, right? Because 64 is equal to, because you know 64 is actually equal to 8 squared, and then y squared is a multiplication, is a multiple of 2, right? Okay, so now we're just gonna apply the property, right? So we basically write it down 8y plus x and then 8y minus x, right? Okay, so now we actually done the factory, right? So we actually done the factory. So this is the solution. You know, if you actually good enough, you don't even need to write it down the property. You just write it down the solution. You just write it down the solution in one step. Okay. Okay, so let's move into question 4. So question 4, you look at question 4, you're thinking about maybe I should able to apply this property again. But the answer is actually no over here, right? The answer is no over here. Even you know 4 can be 2 to the power 2, which is a perfect square, right? But you still cannot using it because the property over here is a negative, right? So okay, so let me write a little bit more clear, I guess. So the property over here is a plus b, a minus b is equal to a squared minus b squared, right? So we need to have a negative over here, but here is actually positive, right? So here is actually positive. So you know we cannot use in the property, right? We just cannot use it because it is different, right? So we just basically leave the question at A, so because we cannot do anything more than that, you know. So basically leave the question at A because we cannot do the factory. So we just, you know, we cannot do any more factory, right? We cannot do any more factory. So we just leave the answer as A is. Okay. All right. Okay. So let's move into the last question over here. So again, for this question, we want to factory. We want to doing the factory. Okay. So first of all, let's look at can we factory out anything before? Can we factory out anything before we doing more steps? So you look at over here, we have a b and then we have a b to the power 3, right? So we have a b and then b to the power 3, and over here we have a negative 2 and a 50, right? So you should be able to know that the greatest common factor among those two terms should be 2b, right? So the greatest common the JCF, the greatest common factor JCF should be over here. Between those two terms should be 2b, right? It should be 2b. Okay. So now you need to do the factory stuff. So 2 multiplied by 25, right? 25 is equal to 50, and then we just write it down a squared, right? We just write it down a squared, b, and then it just minus and then minus b squared, right? Makes sense, right? Okay. So if you're still not sure, then you just plug plug the number back, right? So just basically recheck again and then plug the number back and see it is still equivalent to the left hand side, right? 50. So okay, so let me erase erase it actually. Okay, so now let's do the next step. Okay, so the next step should be really familiar to you guys, right? It should be really familiar to you guys, because now you've seen that we have a 25a squared. We have a 25a squared minus b squared, right? So if you I think upon this point you guys should be able to do it right away. So we finish it just basically 5a plus b and then 5a minus b, right? So basically that is right, because I think okay. So if you are actually able to see it really clear, you should know that 25a squared is actually a perfect square, right? So 25a squared is actually equal to 5a, right? It's actually equal to 5a squared. So therefore we have 5a over here, right? And then we have b squared, right? We have a negative b squared. B squared is also a perfect square, right? So because it is a multiple of 2, right? So you just write down plus b and minus b, right? Okay. So now this is going to be the final solution for question 5. Yeah. Okay. So now this is actually the final solution for question 5. Okay. All right. So now there's only 2 questions left. There's only 2 questions left. Okay, so there's actually 2 questions left. Okay, so now so over here the question over here have some we have to do something else. Okay, so here what the question say is that we need to determine whether each terminal is a perfect square. Okay, is a perfect square. If it is a perfect square, then we need to factor it. Okay, so we actually need to factor it. So that's the requirement for the question. Okay, I will try to make sure we can see the question most of the time. Okay, so now let's actually do the question 1 over here. So the question 1 over here is right here. Okay, so we have x squared minus 14x plus 49, right? So I think we have tons of practice. We're talking about how to actually solving those kind of polynomial, right? Trinomial, right? Trinomial. So I think you guys on this one, you guys should be able to do it right away, because we already have tons of practice, and then I explained really detailedly, right? So what we have over here, we have an x and then x, right? You write down x and x, and then the combination, the right combination, which is going to work over here, should be -7, and then I should write a little more clear. Okay, so it should be -7 and then also -7, right? Right. So okay. So maybe I will try to show you the detail one more time. Okay. So you may ask me how is this gonna work. So over here we have to ask you guys. I mean I talk about this really many times. So I think you guys does understand it. So over here, how the thing is gonna work is that we're gonna doing the cross operation, right? X multiplied by -7, and then over here is another x multiplied by -7, right? So it just basically become -7x and then -7x, right? So it's actually -14x, right? It's actually -14x, right? So that is exactly what we're looking for, right? So that is exactly the term what we're looking for after middle term. So you know the combination is actually right? So you know the combination is actually right. So let me erase those circles. So now is the point we have to write it down the solution, right? So the solution over here should be equal to x minus 7 and x minus 7, which is equal to x minus 7 to the power 2, right? And then you notice this is actually a perfect square, right? As I said before, a perfect square, what you may ask me why it is a perfect square, because 2 is actually equal to 2 multiplied by 1, right? So we don't actually care the thing inside, we just care about the power over here. Okay, we don't actually care to see. We don't care the inside is actually. We don't actually care. You know, the inside is actually x minus 7. The only thing we care is it has a power which is 2. Okay, right? It has a power which is 2. So it is a perfect square, and then we already factor it, right? So we already factor the trinomial, right? Okay. So I think, okay. So this is gonna be the final solution, okay? So this is gonna be the solution of it. Okay, this is gonna be the solution, and then we done with question 1, okay? All right. So now let's move into let's move into question 2. Okay. So question 2 over here. Okay, I'll try to let you guys see the question all the time. So question 2 over here, what we have is x squared plus 9x plus 16, right? So that's the question what we have over here, and then you try to factor it, right? That's your goal. You know, you see there's a trinomial over here, and then you try to factor it, and you want to see it is a perfect square, and the answer is no over here. Okay, this just cannot be a perfect square. You may ask me why, right? So you may ask me why. Okay. You may ask me why. So let me tell you one of the property. Okay, so we're gonna actually recall some of the property to make you guys actually understand a little bit better. Okay, so I think we're just gonna zoom in a little bit. Okay, we're just gonna zoom in. So recall. So we're gonna recall, right? What recall? Well, the property what we have a plus b squared is actually equal to a squared plus 2ab plus b squared, right? So that's the property what we have over here. So this property will be really important to tell you why actually this is not a perfect square. Okay, so let me write it down. No, it is not a perfect square. Perfect. Okay, it's kind of like a little bit miss, I guess. It is not a perfect. Okay, this time it's a little better. It is not a perfect square, okay? Okay, so this is the reason why it is not a perfect square. We have to use this property over here, okay? So basically, as you can see over here, so basically you know that actually over here we have a 16, right? And 16 is actually a perfect square, right? 16 is equal to 4 to the power 2, which is it is a perfect square, right? And okay, so let me tell you why. And the thing over here a little bit more easy to make you understand. So what if we have something like x plus 4 to the power 2, right? And then we're gonna apply the property over here, right? So we have x squared plus 2 multiplied by 4 and multiplied by x, and then plus 4 squared. So that's how we apply the property, right? The property shows us it's actually equal to x squared plus 8x and then plus 16, right? Okay, all right. And you notice that keep in mind, okay, over here you can see the over here what we have over here is x squared plus 8x plus 16, right? And over the question over here is actually 9x, right? It's actually 9x. So that's why you know it is not a so that's why you actually know it is not a perfect square. Okay, so that's kind of like a shortcut. Okay, right? So you guys don't understand it, right? So over here x plus 4 square is actually a perfect square, right? So this one is actually a perfect square. Yeah, right? Right? But in order to have a perfect square, we need to have ax, right? We need to have ax. But over here is actually 9x, right? but over here it's actually 9x. So those are not equal. We need to have ax in order to have a perfect square, right? But here over here it's actually 9x. So you know we actually okay, so makes sense, right? So therefore it is just not a perfect square, right? Okay, and as the question say it say determine whether each terminal is a perfect square, and then the answer over here, the solution over here is actually this part, right? So determine whether the question over here say determine whether the terminal is a perfect square. If it is, you need to factor it. But for question 2, it is not a perfect square, right? It is not a perfect square, right? So you just say it's gonna be the solution. Okay, let me just maybe circle this answer again. Okay, so over here the answer is just this. Okay, the answer is just simply like this solution. Because you can see it is not we cannot actually it is not a perfect square, right? It is not a perfect square, so therefore we just leave the answer as say, you just say no, it is not a perfect square. Okay, I think you guys don't understand it, right? Why it is not a perfect square? Because it is different, right? Okay. So actually, for today's topic, we basically cover, right? We basically cover the same. We basically cover the difference of the squares and the perfect square trinomials. Okay, right? So at the beginning, we actually talking about some really important information, like what is a perfect square, right? Okay. Then after that, we're actually basically doing some question over here, right? So we're basically doing those questions over here, right? Right? Okay. So thank you guys to watching the video. Okay, to actually watching the video, please subscribe to my channel and then like the video. I will be really appreciated. Okay. And if you still have any question, please leave a comments below. Okay, subscribe to my channel, like the video, and also click the notification button on. I will try to upload the video as soon as possible. Okay. So you guys have a good day, and see you guys in the next video. Bye.